Alrighty. So when we left, we were getting our new number, all right, where we put it in and we get a value, okay, for the random sample. Mine landed right at 3. Anybody else is close to that area?
Yeah, I got 3.
You got a 3. Okay.
3.
Yeah.
3.8.
3.8. 3. Okay. Some more 3s, 3.4s. Okay. And honestly, probably what should have happened is our data should have begun to look something like this. We might have got a random one out here at 4 maybe. All right, or a little bit farther. Anybody get one bigger than 4? You got 4, right at 4? Yeah, that's going to happen some. You might get some a little bit farther out. But what do you notice happens to the data? Yeah, it kind of clumps in one spot, right? So we notice that there's a lot less variability when we do it randomly. Okay. And it's not really normal, but, it looks more symmetric than our other data looked, right? So it just looks a little bit different. It doesn't have an obvious skew one way or the other. This is referred to as a random sample because we let random numbers be chosen by technology. And it has really low bias, okay? And the reason it has low bias is because it has that less variability. There's that one single peak that we get there. Okay. And then it just asked me some questions about the two graphs, looking at the difference between them. And you can just kind of sketch those in there on your paper so you have it to look at. But the first one was a convenient sample. It was easy for me just to pick some words. Random sample, we let technology choose the words for us. That makes it a lot more random. It takes our influence out of it. And are we good? Okay. All right. And then we look at what we have left, right? And so we have less variability, lower bias, all that good stuff. Okay. Now let's take a look at number 5. Okay. DeMonte, you're needed. Yeah. Thank you. Go. All right, y'all. Okay, so when we look, is it topsy-turvy day and I didn't know? Okay. Oh, and that helped? Okay. All right. So I'm not a chiropractor. All right. So let's take a look. So how is the dot plot that we did, the random one, the most different? We already said there was less variability. What do you notice about the middle or the center between the two? Where would you say the center is on the random one?
3.
Yeah, right around 3. If we look over here at the other one, where does it tend to look more like? Yeah, probably more like 5. So number 4 has a lower center. Okay. Has a lower center, and that's that makes it a better estimator. Okay, so the lower the center, all right, you're going to get a better estimator there of your data. Anybody got a guess? What do you think is the actual average length of the words in Beyonce songs? Yeah, it is around 3. It's 3.53 actually. Okay. If you took all the words and you averaged them, you get 3.53 is the true population mean for that song. Okay. And so the question becomes, I'm not sure if you're aware of this, but there was this whole big controversy over, does Beyonce write her own lyrics, or did somebody in Destiny's Child write most of them, and all those kind of things. And so the average word length for her songs typically is about 3.64. So based on what we did today, do you think she wrote Crazy in Love? Okay. For all of her songs, the average word length is 3.64. The one we just did was 3.53. Is that close enough together to say that she probably wrote Crazy in Love, or so far apart that she probably didn't? What do you think? It's an opinion. Yeah, I think she wrote it too. Okay, I think she wrote it. But there are some songs where when they do that average word length and where there are upwards of 4-point-some letters, and they really think maybe somebody else wrote those instead of her, but she took credit. So that was a whole big controversy. You can go look that up if you want to, if you're that interested in Beyonce's ability to write songs. But I just like her music, period. So there we go. Okay. Now, the whole reason we do this exercise is just a way to get some real data and talk about the difference between all the different ways that we can collect data. Okay, and what it does. So on the back side, let's get over here to the notes part and let's organize this really quick, and then we'll walk through it all. Okay. So we start with the population, and we know typically we can't get 100% of our information from 100% of the population. All right, it's why we have to have samples. And so the first type of sampling that we can do is a convenience sample, and that was learning target 1. Okay, so a convenient sample, and thank you, bud. And that gives me our first learning target, okay, which was learning target 1. All right. In a convenience sample, it's just easy to reach, all right, or easy to get our data. Okay, so that was learning target 1. It's convenient, all right, like a convenience store. It's easy to run in and grab something and get back out, okay? The same is true about a convenient sample. The second type of sample that we can do is a voluntary response. All right, and with a voluntary response, people can choose to respond. They're not required to. Okay. Each of those two will lead to some bias. All right, and we want to try to avoid bias if at all possible. Okay, so both of those types of sampling, all right, will lead to some bias. It's going to skew my data one way or the other. Okay, the best way or the best sample is a random sample. Okay, and the thing about a random sample, for it to truly be random, it's typically generated by technology. Okay, but let's say that we have a small population. Could we do that whole drawing out of a hat kind of thing? That would be considered random if you have a small population. But for large populations, which most studies cover, you're going to want to use something that's generated by technology. Okay. The nice thing about a random sample is everyone has an equal chance of being chosen. Okay, and it has low bias. And that's what we want. We want the least amount of bias as possible. So those were our 3 learning targets today. And bias skews our data. It overestimates or underestimates the truth. Okay. Just talking about sampling. Tomorrow we're going to talk about a couple more types of ways that we can collect data and what their issues are. All right, so convenience is just easy data to get, people that are right in front of me. Voluntary response, people can choose to respond. Can you think of something where you get a choice as to whether or not to respond to something? Telemarketers, surveys, questionnaires, messages, things like that, okay? And then a random sample, everyone's got an equal chance of being chosen, typically generated by technology, and the bias is just what skews our data, okay? Underestimates or overestimates the truth. All right. So what I want to do is to look at a couple of questions, okay? We're not going to look at the back of that sheet. We're going to actually go over to the ones that I created. Excuse me, and look at those 3 examples, and then I'm going to let you work. Okay. So this is the main part, the notes part that you'll need. Okay. I do sleep with my dog. He sleeps, both of them sleep in the bed with us. I was never going to even have a dog in a house, and now I have 2 in my bed. So, and I told my husband if something ever happened to him, I'd have a house full of dogs before I'd have another husband. So, I'm like, I'm going to rescue all the dogs. All right, so let's take a look at this example. All right, it says, "Orange, you thirsty?" A farmer brings a juice company many crates of oranges every week, and a company inspector looks at 10 oranges from the top of each crate before deciding whether or not to buy the whole crate. Okay, so he doesn't look at the whole crate, he just looks at 10 that are on the top. Why is the sampling biased? Is the proportion of damaged oranges in the sample likely greater than or less than the proportion of all oranges in the crate that are damaged? So let's talk about that, okay? Why is it an issue that he's only looking at the oranges on the top? Yeah, the ones on the bottom are probably are putting the best oranges on top, right? Wouldn't you, if you knew he was only going to look at the top? Okay, so that's definitely going to lead to some bias. All right, the best oranges are probably on the top. They could be more damaged at the bottom. Okay. Would you call this a convenient sample or a voluntary response? It's a convenience sample, right? We're looking just at the oranges at the top. It is a convenience. Okay. And then are there more than likely, let's see, does the sample have more or less damaged oranges than the whole crate? Well, the sample that you're talking about, the 10, is it going to have more damaged oranges or less damaged oranges than the whole crate? Yeah, the sample's going to have less because the crate's going to have more. Okay, so these are the kind of things they're going to ask you. They'll be in those pull-down menus, all right? Things that they're going to ask you about a situation. So you're just going to have to read the situation and see what it's talking about. Okay. All right, let's look at the next one. So just a little different type of situation with this next one. Okay. All right, rock and roll. It says the athletic department at El Dorado Community College wants to learn more about the physical fitness of students at their school, including the number of push-ups that students can perform. To obtain their sample, the athletic department sets up a booth in the center of campus with a sign that says free physical fitness testing. Why is the sampling method biased? Is the mean number of push-ups for the members of their sample likely to be greater than or less than the mean number of push-ups for the entire student body? So let's just talk about what's happening. There's a booth set up, okay? And they're asking people if they want to do a free physical fitness test where they do push-ups, okay? Why is this not going to give me good data for the whole student body? It's voluntary, okay? If I can't do a push-up, am I stopping? No, okay? No, this is a voluntary response, okay? It's a voluntary response. Probably people that aren't in the best shape are not going to stop, all right? If we can't do push-ups, we're probably not stopping. Okay? And so if we think about the people who do stop, all right, who do that, they're probably going to be in a lot better shape than the average person, all right? So the ones that do stop are probably in better shape. Okay? So are they going to be able to do more or less push-ups than the average person? Yeah, the ones who stop are going to be able to do more. Okay, so that being said, this is where is the mean number of push-ups for the members of the sample likely to be greater or less? We're talking about the sample. Those are the people who do stop. It would be more. Okay, it would be more. So you really got to think about this situation that they're talking about. Okay. All right, and then the last one. Again, this is just kind of what we're going to do. All right, looking at some situations. How could they fix it so that it would have less bias? How could they fix that whole experiment thing they're doing so that they have less bias? What does it need to be? It needs to be random, okay? So maybe they could choose 100 students at random. Okay. No volunteers, no choice. Okay, and that's how we fix it. Okay, we need it to be random. Okay, what do you think? That's it, just understanding what those sampling methods are. Okay, all right, your assignment's open, it's 4 questions. Okay, 4.2. 4.2, so you can work on that.